Today we're going to start a new chapter in Newton's laws of motion, right? So what we study in this chapter? Any idea? What we study? Tell me, guys. So what you are going to study in this chapter? Any guess?
So
Am I
the
audible?
different laws and its applications.
Okay, different laws in this application. So what is the most important topic of this chapter that we discuss in detail? So we are going to study something called force, right? And we'll discuss this force in great detail. So anyone tell me what is force? What you mean by force? Just tell me the definition. Whatever you know, you can just express it. Tell me what is force?
Energy required to do something.
So this is what you studied in class 9th or 10th. It is energy. Force is energy.
No, it is
So what you studied, you just express. Okay. So what is force? Now. Siddhant, what is force?
So force is it is an external cause which can change the state of the body or can change its motion.
Very good. Excellent. Questions are tell me what is force?
Or a push or a pull that can influence the body to change its motion or like the shape of the body, the state of the body.
Yeah, that's also correct. Nothing wrong about it. So can we see force? Can we see force?
No, sir.
So what we can see?
The effect.
Excellent. So very good. So definitely we cannot see force, we can only see the effect of force. And that is the reality. Okay. Great. So we know a lot about force. So that is correct. That is correct. So force is a cause. See, I mean, if you have kicked football ever, or if you have thrown something, so when you kick something, you see subsequent motion, but the motion was not present before. Now you are seeing the motion. So there was a change of state of the body. It was at rest, now it is in motion. So every event is like a state, not like a state in capital, it's like the state of motion. So rest and motion are, you can say that two state of body. So football kept at rest when you are kicking, you are certainly changing the state, but you don't see who has changed the state. But you know there was an event called kick. If you call kick as the event, then you can say that it was the event, it was the cause because of which you were able to change the state. So certainly we do see the change of state So our observation is all about the, observing the change of state. But if you try to figure it out that who was responsible for this change of state, then the cause which you find responsible, Newton gave it a name. Now today we call it force. So force cannot be seen. Of course, you can see its effect. Force is always studied in the backward direction, which means you first see something and you try to speculate that who has caused this event. And when you try to do so, then you realize that this something invisible, something unknown is called force. Now, let's say when we as a human being, when we apply the force, we are not force. So let's say if a person is pushing some object, that person is not force. The person is called agent of force. So one should not be confused between agent and force. So of course, we all human beings can be an agent. Gravity is, again, you can say the earth is an agent which can create an effect which we call force. So force is certainly cannot be seen. There's no doubt about it, but we can certainly see its effect, and we try to trace it backward. That if there is some effect in nature, then what must have caused this effect? And then sometime you may come across some agent, and if you ask the agent for the what you did, then he will say, okay, I made some contact. And then if you further investigate what that contact did, then you say there was an interaction, and then eventually come to know this interaction is called force. So we'll come to that. I mean, what exactly is contact? What is exactly is touch? And is it possible to touch any object? Okay, so we'll come to those questions and we'll try to figure out the answer. But of course, if we want to learn something, then we must define it. Otherwise, it's very difficult to make any progress. So force is, or you can say it has been a mysterious subject. There were various interpretation of force. We interpret in a different way. And to make it more mathematical, there is some concrete definition which was put forth. And those definitions, came as a set of laws, which we now call Newton's laws of motion. Now, Newton never gave 3 laws of motion, but still we study 3 laws of motion. Out of the 3 laws, the first is the law of nature. The second law, which we call second law, is basically a definition which Newton proposed to get rid of this, perception. So he wanted to make it a very concrete looking idea. So he postulated the second law, and then third law is simply a consequence of what Newton, attempted in the second law. So if you talk about the law as per the nature governing law, the first law is called the law of nature. The rest two are definition which can concretize the entire idea of force. Without the second definition, which we call law, the second law is basically a definition. Without that definition, it's difficult to start any mathematical journey regarding force. So these are some underlying ideas, and we do have a lot, large variety of definition. We'll come to that, okay, one by one. There is no need to write much, so these notes are well written already. So I'll just go through the definition, okay, one by one. So let me show you definition, and you can, what you said is correct. What is force? What you said? Force is? It
So I
is a
said it is an
physical
external.
cause. Yeah, it is a physical cause, because the cause means you cannot see it. So it's a physical cause which, when acted upon any object, then it tends to change the state of rest or motion of any object, or sometimes it also tends to change the shape, size, and dimension of the body. So force can cause 2 different types of changes. One is called the state, change of state in terms of motion. But there is a third property of force. It can also affect the dimension, or even the shape. Okay. Now, the course is divided into two parts. So what you are going to study now, the Newton's laws of motion, friction, and dynamics. Up to first few chapters, we are going to discuss about the change of state of motion only. But the chapter which we will study at the end of the class 11th, which we call properties of matter, there again we will bring back the force into picture, but the same force will be doing something different. Okay. So the force which we bring back to picture, that force will actually make changes to the shape, size, or dimension. So we will talk about deformation, change of length, change of figure, change of volume, and so many other things. So that aspect is studied in detail as a separate topic in physics. And as of now, you're going to study the only the force related effect. I mean, of course, force can produce many effects, but right now, what we are interested only force related, I mean, effect. It is clear what I'm saying?
Yes, sir.
So force definition is clear. What is force? You can read this force. It's a physical cause which when acted upon any object, then it tends to change the state of motion of any object, or it tends to change the shape, size, or dimension of any object. Okay, so after that, we need to know something more. So we'll talk about classification force. Okay. So force is classified into variety of categories. There are many ways in which you can explain the force. And these all are a matter of convenience that gives you, okay, to classify the force in a way which makes the study of force a really easy job. So what I'll do is I'll draw this again for you guys. Okay, it will give you some more perspective. Okay. So I think the force definition is clear. I always
Yes, sir.
wanted to save time, but there's no save time. So I'll just explain. It is the physical cause which, when acted upon any object, then it tends to change the state of motion of the object, or it may tend to change the shape, size, or dimension of object. So that's a simple definition of what is force. Okay. And remove this definition just to save some space. Now, as we are moving, forward in this chapter, I will request all of you, please do focus on the definition. If you're not remembering the definition, probably you're not going to study physics. I mean, understand physics in a better way. So definitions are the most important aspect of learning physics. So I hope you all remember the definition. So can you recall this, force definition and explain to me, anyone? Rugved, tell me, what is the definition of force?
Force is a physical cause. Force is a physical cause when acted upon by an object.
Hmm. Yeah, go ahead. Try to realize it. I mean, what should be the definition, and then try to express in some sentence words.
I have to explain it also.
Yeah, you have to explain it.
Force is a physical cause when acted upon any object. It tends to change station of motion of object when we
So what force can do? It can do only two things. Either it will accelerate or distort or
decelerate.
deform. So there are only two things, right? Right
Yes.
now we are talking about which part? Right now we are only interested in the motion
Deform.
part, right?
Hmm.
Yeah. So what is the definition?
Force is a physical state when acted upon any object.
Force is a physical
Physical cause.
cause. It's a cause. See, the entire learning of physics is cause and effect. So you always study only cause versus effect, and cause will be caused by some agent. Okay. Agent can be gravity, sometimes it can be some rope, some spring, some pulley, you, me, whatever. So we all are agent. Force is something invisible. You don't see force, you see only agent of force. Okay.
Yes.
So
Force
Earth is applying force on all of us. Do you see the force or do you see the agent of force?
agent of force.
So you need to be very clear with all those definitions. Yeah. So now tell me, what is the definition?
Force is physical cause
Cause.
when acted upon any object. It tends to change the station of motion of the object.
Station,
State.
state of
Motion of object.
motion. Or
Change size, shape of the object or dimension of object.
or dimension. Try once again. You can make it better next time. Try once again.
Force is a physical cause when acted upon any object, tends to change the state of motion of object or change shape, size or dimension of the object.
Keep on repeating it in your mind. Okay. While questions are you tell me the definition. See, when you say definition to whenever I am asking a definition, don't try to answer it. Try to feel the definition and then express in language which you prefer. Yeah. So tell me, what is force?
So force is a physical cause which acts on a body and produces change in state of motion or change in the uh, shape, size, or dimension.
Very good.
Object.
So yeah, that's very accurate. But you can always further modify and make it more refined when you define something, right? Always remember the definition in physics is the backbone of theory. I mean, backbone of all the formula or derivation. So when you know the definition, probably the chances of making a mistake in the conceptual question is very less. So when you're solving the MCQs in which you have to answer like more than one option correct type, and it's a purely theoretical, then definition will help. Okay. So in this chapter, we are going to study which part of force, the motion part or the deformation part?
Some motion.
Only motion. So for deformation, we have a separate chapter. Okay. We have a chapter called properties of matter, elasticity. And in the chapter of elasticity, we talk about the deformation, right? So this is the separate chapter. We'll study differently. Now, the next part is, once you understand the force, okay, you can only understand, you cannot see it. So once you have this understanding that force is a cause, then the cause cannot be seen, the effect can be seen. Everything is studied in the reverse order. So we look at the effect and we try to figure it out the cause behind it. And that is how we are going to develop our intuition in this chapter. Okay. So now we have classification of force. Okay. The next concept is called classification. Okay, I'll light quickly. Classification of force. What is classification of force? You classify as per the requirement, right? So we all classify things in our life because it makes life really simple. Classification of force. So the first classification is called based on system. So what is the meaning of based on system? So for that you need to understand what is system. So first let me write down. So based on the concept of system, we have given two different categories to the force. And these two categories are internal force, and then we have external force. So let's say two siblings are fighting with each other. Okay, and you are the observer. You are watching it. You are watching it, and then if you treat each person, each boy or girl, each person as a separate entity, you think one person as one system, then the fighting is between two systems, right? But if you assume both the boys as one system, then fighting is happening within the system, isn't it? So it depends on what system you assume. Understood? So let's say in a family there is a like a friendly fight. In the friendly fight, you treat each person as one system, and then you see who has punched more and who has punched less, and then you decide the winner. Okay. So when you're taking each person as one system, then the force on each person by the other will be which force? Internal force or external force? Tell me. So if we have A and we have B, so A is applying force on B and B is applying force on A. And if you choose A as a system, you're calling A as a system, you're calling B as a system, separate system, then the force experienced by both will be which force? Internal force or external force?
External.
Correct. Now, if I say this entire thing as one system, then the same force becomes,
Internal.
which means a force will have no particular name. It may become internal or it may become external, depending on what you assume as system. So the question is, system is what is system? What is the definition of system? So system is a part of universe. It is a part of universe on which you concentrate for the purpose of study, research, analysis, experiment, etc. So as an observer, whatever you consider becomes the system. Understood? So it is all about assumption. So system is an assumption of an observer. Okay. So what is system? System is an assumption of an observer. It is part of universe. And why it is important? Can you explain? Okay, what I'll do is I'll define on a different page. It will become really bad. So no, I'll put it here only, just not exactly here. So the idea of system is very important. I'll come to that. Many ways you can think about. So the why it is important, because we cannot think about, we cannot analyze the entire universe at once. So you narrow down your focus so that you can have a better observation. And so you keep on narrowing down this process till you make sure that, okay, you are able to observe things clearly. So the assumption is like, if we have multiple objects in motion, then we cannot, analyze all motion together. So what we do is we assume one block or one moving object as one system, and then we try to analyze its motion. Then we go to the another block, we assume that as a system, then we analyze its own motion, and then we make some inferences. So it is a common practice that make a small system so that the observation can be made in a better way. So that's why this idea is there. And because of this idea, we have a naming convention of force. So force is again unknown, but you can classify as internal or external depending on the assumption you have made while studying it. Okay. So what is system? It is the part of universe on which we concentrate for the study of for the purpose of study, analysis, research, experiment, etc. Then the rest part of universe except this system is called surrounding, and the imaginary layer separating the system with its immediate surrounding is called what you call boundary. So this is simple definition that one should be aware of. So system is clear. What is system? Tell me, guys. System is clear. What is surrounding and what is? So these are three terms which will come across very often in physics while studying any textbook. And system is a very essential commodity, you can say. As a researcher or observer, you start with, you design your own system, and then you try to explain the things to the world. Okay. So as I said, how it works in physics, this chapter, in real life, it's okay, but in physics, let's say you keep two blocks one over the other, and the second block is kept on the ground. Okay. So each block applies force on each other. So definitely gravity is pulling both of them, but because gravity is pulling the M1 downward, but M2 is stopping it. So there is some force of interaction acting here. And gravity is also pulling M2, but again, M2 cannot go downward because the earth is stopping it. So again, there is a force of interaction here. Now tell me, guys, if I assume M1 as a system, M2 as a system separately, then the force of interaction will be which force? Internal or external? So if you consider M1 as a system, then whatever force M2 will apply, which force will be? Internal force or external force? What we can say?
External.
Correct. You can say this is external force. And what M1 will apply on M2 will be also external. Yes or no?
Yes, sir.
What ground will apply? The surface of the ground will apply on M2 is also external. Right? And what earth will attract, that is also external. So there are many forces acting on every object. And because of the assumption of the system, you can call this is external, this is internal, and vice versa. Now imagine if you assume both as a system, the block as system, then which force is external, which force is internal? Can you explain the external versus internal?
So the force of interaction between M1 and M2 is internal.
Correct. So the whatever force M1 is applying on M2 or M2 is applying on M1, that will become internal. But the force of ground on the M2 will be
External.
very good. And the gravitational attraction will be
External.
external. So the internal and external idea is clear. It is the assumption. So we always, make a group of object as one system, and then we look for that which force is acting external to that assumption. So for example, these are very common question you will come across in physics in this chapter also. So let's do this common practice. If you have a block like this, another block is in front of this block, another block is kept in front of this block. Okay. And I'm pushing this object with some, so I mean some agent is pushing the object, and the magnitude of force that is being applied is F. So how many interaction will be possible? So interactions are possible like between these two. Okay, just a moment. And of course, the interaction between these two, Earth, and of course the gravity is always there. Now, if I assume the entire collection of block as one system, then what is the horizontal force acting on the entire system?
The force.
Only the applied one, right? The F, right? So this force is external to which block? M1, M2, M3, or all three together?
All three together.
Yeah. Now, what will happen if I take each block separately? If I only consider M1, what will happen? The F will act from the left, but right will also have some value, isn't it? As of now, we don't know, but it will have some value. So the external force on M1 will be from left and right both. Yes or no? Apart from the bottom. We'll come to that later on. And similarly for M2 will be what? So what force M2 will experience? The effect of this force here, right? And again, M2 will also experience this force from this side. And what M3 will experience? So if I name it, let's say if I call it R1, if I call it R2, and let's ignore the vertical force, just think of the horizontal force. Tell me, what is the external force or forces acting on M1? Only tell me the horizontal force. Don't tell me the vertical force. Tell me, everyone, what is the external force on M1? If I think of M1 as system, then
F and R1.
correct, F and R1. And similarly, what is for M2? What is the external force of on M2 if I consider each as individual system?
R1 and R2.
And for M3?
R2.
R2, very good. Is this clear to everyone? Rugved,
Yes, sir.
Yes, sir.
Siddhant, it's clear?
Yes, sir.
So it's very simple. Now, if I change the assumption, if I say, what if M1, M2 is my system? So what is the external force on M1, M2 taken together?
F and R2.
Very good. What is the external force acting on M2, M3 taken together?
R1.
Very good. So do you guys realize the assumption and its effect? So what is the external force if I take all three as system?
F.
Very good. So assumption makes the description. And therefore internal and external is nothing of some sort existing in the world. It is the assumption which, create this difference. And therefore, as you change the assumption, the definition of internal and external will change for the given problem. But it is important and good to know this classification. So I hope the classification is clear to all of you. So the classification of force based on system is clear.
Yes, sir.
Yes.
So we have to not stop here. We have to go to the next classification, which I will draw in the this page. So after the first classification, the next is called based on. Based on origin. Okay. Like how this cause came into being. Now that is also important. How the cause came into being. So based on origin, the classification will have two varieties. And this is the most important part of classification. So the first variety is called contact force. Just name it. Contact force. So the other variety must be
Non-contact.
non-contact force. So you can clearly tell me the Earth's gravity, does it require contact? Or it can act from anywhere?
It can act from anywhere.
So when you jump, you're not in contact with the Earth, but still you are pulled back to the Earth because the force of gravity is non-contact force. So the contact is not required. I mean, you may be in contact with the Earth, but that is not the cause behind this force. But there are some force which requires some contact. For example, you cannot slap someone without touching it. Or can you slap without touching it? It's difficult, right? So there are some force which requires, physical contact, then only it can be exerted. So the idea is simple. When I say contact force, it means the force which requires some physical connection in order to be exerted. It's called contact force. And what is non-contact force? The force which doesn't need any physical contact in order to be exerted. Okay. So now to make things further easier, we have a next level of classification. So the contact force we have further classified into two categories. And at every stage, whatever definition you're learning, make sure that you remember the definition. Don't just read it out. So there are two types of contact force. For example, if you are standing on the surface, you are standing on the earth, on the floor. So what kind of contact you make? You cover a certain area, right? While you stand, isn't it? So while you stand, the contact which you make with the ground is covering some area, yes or no?
Yes, sir.
But when you write using a pen and you press it against the paper, the area becomes very small, isn't it? So you're like touching at a point. It seems like, yes or no?
Yes, sir.
Of course, if you zoom it, you will see some surface, but the area is really small. So based on the area of contact, we have classified the contact force into two parts. One is called surface contact. Another is called point contact. So for example, technically, if you tie someone with a thread and if you try to pull the string, then the string will be pulling at a point actually. So we name it point contact. So we have further classification. The surface contact will have various category. So we have category called normal reaction. It is called normal because this force is always normal to the surface which you make in contact. And this is a distributed force, which means normal do not act at a point. Rather, when you are standing, then every point of your foot, which is making contact with the surface, is exerting the normal reaction. And the net normal is the sum total of all individual normal. So surface contact is called distributed force. So there's a name for this. So when you are wearing a shoe or slipper, so the purpose of shoe or slipper is that the force by the ground is not distributed over the surface. And because it is distributed over the surface, then the pressure will be less. So bigger the area, lesser the pressure. And as the pressure is less, you can walk or run comfortably without denting the surface. But imagine if your foot is like a pointed tip of a pen, it is like a point. And even if you stand on a very hard surface, there's a chance it will crack the surface. Isn't it? Because the pressure is tremendous. Now, when you try to walk on a desert, do you find it difficult or easy? Okay, perhaps you haven't experienced, but it is slightly difficult to walk on the desert, isn't it? So what is the reason why it is difficult?
Because our feet sink in the sand.
Because the weight creates a pressure, and that pressure is good enough to dent the surface. So kind of you go inside the surface, isn't it, while walking? But the camels are able to run easily. How? So the desert camel will have the, their foot is fluffy. It will expand. And that is how it creates the bigger area of contact, which in turn reduces the pressure. So it will never dent. So they can walk easily. So you can imagine like a spongy fit. And once you press it, it flattens, covers the bigger area, which prevent from sinking inside, and therefore they are able to walk with ease. Okay. So the normal reaction is one of the famous in normal this surface contact force. The other is again very famous, which you again know. So other is called friction. So friction also comes under the distributed force classification. And again, friction will have now three categories. So we further classify friction. So one is called static friction, which is slightly complex thing which we'll try to understand. So the nature of origin of these forces are different. That's why we have different names. So we call it static friction, which is having a different mechanism to create the resistance. Friction here doesn't mean the rubbing of things. Friction means the resistance, okay, which they offer. Okay. The next is called dynamic friction. Intuitively, whatever you know about friction, the common human intuition of the friction is the dynamic friction. So whatever you have the idea of friction so far in your life is about the dynamic friction, because friction is something really more deep than the dynamic. We have static, we have dynamic, and we have third variety called the rolling friction. So why three different names for the friction? Friction means opposition, but opposition can have variety of mechanism. Okay, so in some situation, as we change the mechanism of opposition, we change the naming convention also. So we have static opposition, we have dynamic opposition, we have rolling opposition. And these three types of opposition will have three different internal mechanism of working. So what you know so far, I mean, if you have some intuition about friction, then that must be the dynamic friction. The other two friction which I have written, you haven't developed that intuition so far. Okay. So we'll see that. What is this exactly friction? Okay, so under the category of point contact, we have, I mean, many forces, but we'll particularly look for two forces. So we have tension force, we call tension, which is the property of rope, string, wire. And we do have something called spring force. So these two forces will come under the category of point contact. A rope is attached at a point, a spring is attached at a point. So it is not distributed mostly. So we treat as a point contact force. Okay, so I hope the idea of contact force is clear. What is contact force? First of all, for contact force, you need to, I mean, if you want to feel it or exert it, you have to be very close to the surface on which you want to exert, and close enough to feel as touch. Okay. Then what are the examples of non-contact force? We know gravitational force. Any other force you know, which are non-contact force? So you must have heard about the repulsion between the charges, right? The two charged particles can attract and repel without actually being in contact. Is it yes or no? Tell me.
Yes, sir.
And it is the electrostatic force which is the cause behind the formation of most of the ionic compounds. Okay. It is the electrostatic force which is the reason behind the formation of molecules also. Formation of complex compound also. So in chemistry, what we call chemical bonding, in physics we call force. So a chemical bonding is a different way to interpret force. Okay. And what we call bond length is basically the separation at which the force will balance out each other. That is also very interesting to know that when you say H2, and when you chemistry, you represent as H, some line you call H. What you're trying to interpret or say to the world that, see, there are two atoms. There are two atoms with some orbit. And when the separation between them is this R naught, then the attraction and the repulsion both between the atom will be 0. So the repulsion and the attraction both are balanced, and the distance at which it is balanced is called, what we call? The distance at which the attraction and repulsion balances is called? So you name it by the term bond length. Okay. And bonding means basically the force only. And the beauty of bonding is if you try to go away, the force of attraction becomes dominating. And if you try to come closer, the force of repulsion becomes the dominating. And that is how you are kind of stabilized at that position. If you go right or left, then the force will try to bring you back either through repulsion or through attraction. So do you all understand what is bond or bond length? Hello.
Yes, sir.
So when you study about salt, you know salt, sodium chloride. Have you heard the name salt?
Yes, sir.
Then how sodium atom is holding the chlorine ion? Okay, how they attract each other? Is it contact force or non-contact force? Which force is there?
So non-contact.
It is certainly non-contact, and the nature is called electrostatic force, okay, or Coulombic force. So there is a name for this. So the entire world of chemistry is based on the non-contact force. But for your surprise, the entire nature of force, whatever I have discussed as contact force, now this is a big surprise for all of you. The entire idea of contact force is based on non-contact force. Technically, no force in the universe is contact force. So the contact force definition is clear to all of you?
Yes, sir.
Okay, so to understand better what are these exactly, every name convention which you are looking at here on this screen, these all are matter of convenience. So because study is all about convenience, so we make some convenience so that we can have a better explanation. We can explain to the world how things are there. And these are the classification, or these are the naming convention which facilitate those explanation. Okay, so the whole idea is the feasibility of explanation. Now the reality is a bit complex. So if you want to go into reality, then we have to understand the fundamental nature of force. I'll come to that once I complete this classification. So the next classification is called based on nature of, or you can simply say based on frame of reference. Now this is slightly difficult as of now, but just you need to know frame of reference. So I think it's a very common experience that when you go for a merry-go-round, do you all feel a pull outward, like a pull which is pulling you like outward in a merry-go-round? Have you experienced this? Some sort of outward pull, the centrifugal force?
Yes,
Yes.
sir.
That feeling is actually real. That feeling is real. But the idea is what you're feeling is not real. So actually, no one is pulling you outward. Then still, why you experience that? So the entire experience is called due to inertia. So the idea, the inertia is letting you feel in a different way. So what is inertia doing actually? So if you're in a car and the car is going at a very high speed, and then suddenly the car has to take a left turn. So if the driver will take a sudden turn, what you will feel? A force towards right or left?
Towards right.
Towards right, correct. You know why this? Why you experience this? So the person in the car is also having the same velocity. Now, as car will turn, you will not turn because your inertia is to go this way. You want to go this way. But the car has turned like this. So you as a person is going to hit this part of car? Yes or no? Because this is your inertia. So you will try to maintain the direction of motion, but the car has turned. And in the time when car has turned, you are not able to turn or make the same turn. So rather you will hit the the new face of car, because it is like a reverse process. It is like you are moving that way and car has come in front of you. So the car door will come in front of you, you will hit it. Now that is how you feel this force, the outward force. So this inertia is giving you a different perspective. You feel like someone is pulling you outside, but the nature is trying to maintain the state of motion. Of course, when you are sitting in a car, you are experiencing some force because of the surface on which you are sitting, because of the force you are holding something. And this force will tend to change the state of motion, like it turning the direction. But they're not able to do it completely. And therefore, you will have some inertial character maintained in the initial direction and you hit the turned car surface. So what you feel face is now the door of the car, and that is how you feel the outward pull, which we call the centrifugal force. But these experiences are due to the frame of reference. It is the car frame in which you feel it. In ground frame, the explanation is different. So in ground frame, we say it is the inertia which is because of which you have felt. But how you will explain this in the car frame? So you will say, I was pulled by someone in the outward direction. This is how I will explain in the car frame. So the force which is not actually existing, you're naming it because you're feeling it. And because you're feeling, because you're in a different frame of reference. And that is why we have a classification of force as per the frame of reference. And the classification is called a real force, the force which actually acts, and sometimes the perception. I mean, you feel there is a force, but actually there is no force. So your perception is real. You actually feel it, but your explanation is wrong. Okay, so this is called pseudo force. So pseudo force is some sort of your imagination that you feel it. And these forces came into picture because of the difference of change of frame of reference. So we have a frame called inertial frame. So inertial frame So what is the inertial frame of reference? So you know the inertia, what inertia? Inertia means tendency to maintain the state of rest or motion, isn't it? So that's why the inertial means a frame which can maintain the its velocity. So any frame which is either at rest or moving with constant speed, constant velocity with respect to ground is called inertial frame. So I'll just mention this quickly. A frame which is either at rest or moving with constant velocity with respect to ground is called inertial frame of reference. Okay, understood? So frame which is either at rest or moving with constant velocity with respect to ground is called inertial frame of reference. You can remember this way. Inertial frame is the frame which maintains the inertia is inertial frame. So what is non-inertial frame? Tell me quickly what is non-inertial frame?
Which does not maintain inertia.
So there is a nice way of saying the same. We call a frame which accelerate, because the rate of change of velocity is called
Acceleration.
acceleration. So if velocity is constant, the inertia is there. If velocity is changing, the inertia is changing, right? Any accelerating or rotating frame, like when you go for merry-go-round, it's rotating frame, is called non-inertial frame of it's called non-inertial frame of reference. It means if you are sitting in a bus or car which is accelerating, or if you are in a merry-go-round which is rotating, the moment you are in such situation and if you're trying to observe the motion, you become a non-inertial frame observer. And the pseudo force comes for those conditions that, okay, when you are sitting in those frame, then you tend to experience something extra, which is not real. So we call pseudo force. So we'll come to that in detail. We have a topic called non-inertial frame of reference and pseudo force. So we'll study separately, not now. So frame of reference is clear. I think I have explained the frame of reference definition in kinematics. What is the frame of reference? Dan, tell me. What is frame of reference?
So frame of reference is basically the position of the point with respect to the origin.
That is called the position vector. What is frame of reference? Questions are tell me. Rugved, tell me.
So it is used to explain the relationship between the observer and the moving body.
Going good. Tell me more. The word frame of reference is a jargon which we use for observer. That's it, isn't it? So frame of reference means the guy who is watching. It's some fancy name way of saying. So what I defined was any observer attached with coordinate system is called frame of reference. Do you remember this? And I talked about the mathematical observation. See, as a person, you can give qualitative value, but the coordinate system will give you quantitative value. So when both are there, when the person is there with respect to the, they with coordinate system, then together we call frame of reference. I hope this is clear. So the frame of reference is what? Come on, you should know this frame of reference. I hope this is clear now. Tell me, guys.
Yes,
So
sir.
frame of reference, you see, again, if you're not remembering the definition, things will be difficult for you. And don't remember by mugging up. You realize it, you can automatically remember. So tell me, who will tell me? Rugved will tell me. What is inertial frame, Rugved? What is the inertial frame of reference?
Which is at
Mhm.
a frame which is at rest or moving with constant velocity with respect to ground.
Okay, very good. So what is non-inertial frame?
A frame of reference which is accelerating relative to the ground.
Correct. Accelerating or rotating. Because in a way, rotation is also acceleration. Okay. Okay, tell me when an object is said to be accelerating, persons I will take. When an object is said to be accelerating,
When it is not moving with constant velocity.
so how to not move with constant velocity? In how many ways we can achieve this?
If the velocity is constantly increasing or constantly decreasing.
What else? Imagine you have a bicycle and you are moving your bicycle at a constant speed on a roundabout. Are you accelerating? Yes or no?
Yes, sir.
So why are you accelerating?
Because the direction is constantly changing.
Because the direction is constantly changing, which means the velocity vector is changing. Although the magnitude is not changing, but direction is changing, so velocity vector is changing, and every time we have a change of velocity vector, we call it is accelerating. So acceleration can be produced in two ways: by change of direction, by change of magnitude, by changing both. And therefore, the non-inertial frame can come in all the three conditions. When you change the direction, there is a non-inertial frame. There is change of magnitude, non-inertial. Change of both, certainly it's non-inertial. Okay. So this was the classification. I mean, of course, we'll study in detail about the classification later on. The last classification, which you can ignore as of now, but it is the most prominent one. in the future is called based on nature of work done. So based on nature of work done, again there are two categories. One is conservative force, and we have non-conservative force. Now this is a part of chapter called work energy and power. So there you are going to study in detail about the same. But as of now, you just should know, or I mean, just awareness is good enough. So conservative is called a force which depends on path and this is independent of path. So it's very simple. A force which depends on path is called conservative, and the force which has nothing to do with the path which you take is non-conservative. So it's of course a different definition altogether. Now we'll come to something called, all these definitions are, as I said, it's a matter of convenience. So we'll try to understand what are the reality of force. Are these forces actually in nature present, or we have just simply named it? So the answer is everything which I have written here, the internal, external, contact, non-contact, and all, real, pseudo. These are some, you can say, high level assumption. High level means a top level. I mean, we don't want to see the reality. These are not realities. These are matter of convenience. You have named it because you find it easy to, deal with. So I'll come to this part. Okay. Also, one should be aware of some symbol notation that we use in different contexts. So for normal action, the symbol we are going to use is N. For friction, what we use? A symbol is small f. So for static, we do have a separate symbol Fs. Dynamic is also called kinetic friction. So there is symbol Fk. And for rolling, you can say Fr. For tension, we continue with the symbol T. For spring force, we continue symbol F. We can just write FSP. For gravitational force, you can call Fg. And in different contexts, we write it differently. So we generally write mg. Other force, we're not supposed to know right now. As the chapter will come, it will come to. So these forces and the symbols are very typical. We are going to use it to represent our question accordingly. Okay. Now we'll talk about something reality. The forces in nature. What are the real forces in nature? So in a reality, in nature, we have only 4 types of force. So there are only 4 types of force. The first is called which force? The first is called strong nuclear force, and this force acts within the nucleus It is mysterious in nature. No one knows exactly what exactly it is. We do have some models, some ideas, some definition, some naming, but this force is still mysterious to the world. Okay. So a lot of mystery is still around this force. We do have some theory for this. None of them are accurate. It is so powerful that if this force will, is spread out in the universe, then Earth will shrink to a size of a pebble. Imagine how powerful the force is. So you can probably, if this force will come into picture, then you can shrink Earth to a size which you can hold in your hand. But luckily, okay, this force is a very short range force. It is very short range force. Extremely and therefore we are saved by this powerful but mysterious but a very short range force. So you will never come in influence of this force. It is acting within a dimension of Fermi meter, which is 10 to the power minus 15 meter. Okay. What is next? So this next is called electromagnetic force. Now, electric force and magnetic force are not different in physics. Both are same. We name it electromagnetic force as a single name. The word electric and magnetic was because of the historical development of the science. But today, at present, these two forces has combined into a single force, which we call electromagnetic force, and there is no, distinction which is, made for the same. So in today's world, we don't talk about electrostatic and magnetic as separate concepts. It's the same concept with two different interpretation. So now the electric and magnetic are called two different interpretation of single force called electromagnetic force. Okay. The third is called weak nuclear force. So this force is responsible for various nuclear decay process. So this force is playing a big role in the beta decay. I know none of this is making sense to you, but I'll tell you what is this weak nuclear force. A decay is a process in which something decays into something different. Nucleus. A nucleus will decay into something new nucleus. So nature says that before decay, who was holding it? Decay means what? You disintegrate. Okay. So let's say if you're standing on your foot for, let's say, 10 hours, then you may collapse because your ability is not to stand for 10 hours. So you stay there for a long time, but eventually you fall on the ground. So the question is, what kept you, standing for such a long time? So you say that, okay, the food which you ate, okay, that, that makes you, that gives you the energy. We do have some energy storage like mitochondria and all, and glucose also. So like the body is able to, hold a large amount of energy in different formats, and it uses that energy when there is a need and there's no, supply. But eventually this energy goes off and then you just simply fall back. Similarly, in a nuclear decay, when some nucleus is decaying into some smaller nuclei, there is some force which is holding them back from decay. Actually, it is preventing the decay, but they are not very strong to keep it forever. So that's why every nucleus will eventually decay in nature. So everything will decay, either today or tomorrow. The time may be in the billion of years, maybe trillion of years. So we will not be able to observe it in our lifetime. But theory says that everything will decay eventually. So the weak nuclear force is acting between the subatomic particles like neutrons, protons. So these neutrons are neutrons, but they also decay. A neutron may become proton, a proton may become neutron. Within nucleus, they keep on converting from one form to other form. And they exist in their own form for some time before the decay. So whatever force is responsible to keep you in one format is called weak nuclear force. Okay, so that is a basic idea you should know about. And the last force, which is the weakest of all force. So this, the way I'm writing is the order of force also. So the strongest one is the first, the next strong is second, third is the third strong force, and the weakest of all forces is one. So you can imagine gravitational force is the weakest of all forces. But nevertheless, this force is, holding the universe together. Because the gravitational force is everywhere and it has pervaded the entire universe, traveling at the speed of light. But this is in the context of classical theory. Now we have a different theory about gravitation. So we have something called space-time curvature. And as per the Einstein general theory of relativity, the entire idea of gravitation which Newton gave, which Kepler gave, Tycho Brahe gave, all are now obsolete or kind of very much inadequate. And now there's a different explanation, which we called general theory of relativity given by the Einstein. So we now have a very different explanation for the gravitation, but we are going to stick to the old definition, old idea of Newton. So we are going to stick to the Newtonian definition of gravitation. The entire mechanics that we are going to study will be based on the Newtonian idea. We are not going to deal with the idea of Einstein in this chapter. Okay. So we'll bring the Einstein theory somewhat in a chapter of magnetism, EMI. Before that, we'll stick to the old ideas of science, what Newton proposed to the world. Because that is a very, again, you can say it's a good convention. And as a matter of, convenience, the Newton's laws are very easy to use. The failure of the Newton's law is of not a big significance for us in our day-to-day life. But it is having big significance when it comes to the cosmological studies, when it comes to the study of subatomic world, the world within nucleus. When you try to understand what is happening within the nuclear dimension, how the world is, acting, behaving there, then of course we cannot stick to the Newton's idea. So Newton idea is for the macro world, the bigger world. And Einstein is for the smallest world, which we haven't explored much. So they have different importance. So though we are going to study everything highly inaccurate, but that inaccuracy will never affect our day-to-day life. Because if you're walking, let's say, from here to your garden, and if you travel by 1 nanometer extra, it will not make any effect, isn't it? But if a proton is moving towards the nucleus, and if it will deviate by 1 nanometer, it will miss the nucleus. So their nanometer matters, isn't it? Does it matter in our life? Nanometer? Does it matter?
Also,
So you can imagine that the kind of accuracy we need to carry out the nuclear reaction is highly insane. And therefore it's highly difficult. And therefore we need to be extremely precise in our calculation. And the precision goes to the 10th place of decimal. So when you go to that precision, the Newton idea will never work. So that's why we need to invoke a superior, a better idea, which is the Einstein. And going into future, we are going to surpass even Einstein idea. Something else will come. Hold on. you will be witnessing something really magical in 2029. Okay. What will happen? You come to know in a newspaper and something, some internet, somewhere will come to know. Don't worry. So wait for 2029. The world will see the next magic. Okay. So these are the actual forces in nature. And as you go from top to bottom, the strength will, I'll make it reverse. Strength wise, it will grow like this. So even the weak force is not the weakest force. Which is the weakest force? Gravitational force. What is the nuclear force? It is within the nucleus. So which force we actually experience in our life? So when two atoms interact with each other, which force they actually feel? So when the atom interact, they feel mostly which force? Electromagnetic force. So this is the force with which we all interact with each other. So can you touch your desk right now? The desktop or the table? Can you touch right now? Tell me, guys, are you able to touch your table?
Yes.
Do you feel something?
Yes.
What do you feel? Can you explain what you're feeling? So your hand is a sensor, yes or no? So we call skin as a sensory organ, right? How many sensory organs we have?
So 5.
5. So skin is also one of them, right?
Yes, sir.
So when you say that you're touching the table, what you're doing exactly? You're sensing something, right? There is some sense. What is that sense? How the brain is activating that sense? And that is very interesting. The reality is, it is the atom of your hand which is interacting with the atom of the table. But this interaction is only possible when they are really close. And still they are not touching it. But they are close enough to exert force. And our brain is able to sense the force which we interpret as touch. So what exactly is touch? It is the interaction of atoms. Which atom? The atom from your hand and the table. The question is why we are not able to feel that force? Because that force requires some separation to be felt by the brain. So when you go really close to the table, you start feeling that force. And the moment you start feeling the force, you must understand that the atoms are really close. But is it possible to touch two atoms? The answer is no. We cannot touch two atoms. So when we have atoms, I'll draw just one orbit to represent. When two atoms starts coming very, very close, the two nuclei start repelling because of the like charges. And the orbiting electron, they feel the attraction because of the other nuclei. And the two electron will also repel. So we do have repulsion between the electron, repulsion between the nuclei, attraction between the electron and the nuclei. So at this separation, the touch has started. That's it. But the question is, when you're touching something, are these atoms actually making the physical touch? The answer is no, because the whole idea of atom is only symbolic. Do we know what atom is? What exactly is atom? So it is called the region of influence of nuclei. So the extent up to which the nucleus can interact with its surrounding electrons. And the beauty is, because we have a neutral atom, so these electrons will distribute themselves around the nuclei in such a way that after a certain distance, the effect of electron and the effect of nuclei is exactly balanced in a perfect harmony, perfect sync. And beyond this region, the effect of nucleus cannot be felt. We call this as dimension of atom. So there's no physical boundary, there's no physical layer to an atom. Atom is an idea. It is called the region of influence. So this is the definition of atom. It is the region of influence. And beyond this region, you cannot influence something. That's why that's called your dimension, your restriction, your, I mean, you can say size, shape, whatever, that's called atom. So when two dissimilar atoms try to interact, they eventually stop at some separation. They cannot keep on coming closer and closer forever, because their region of influence will never cross each other. So you stop at a separation, and that's how you define, because when you come really close to each other, you start exerting force on each other. And that force gets transferred to the brain as a touch. So if you are sitting on a chair, whatever you're experiencing is a non-contact force. But for this non-contact force to come into picture, a certain separation is required. Unlike gravitation, in gravitation, which is also non-contact force, but that can be exerted from any distance. But the touch is that non-contact force which requires almost physically, the perception wise, it's a zero contact, I mean, zero separation. It's like a zero separation non-contact force, because the separation is almost zero, we term as contact force. So the idea of contact force and non-contact force is clear to all of you? Tell me, guys. Do you realize what I'm
Yes, sir.
saying? See,
Yes, sir.
every force is non-contact force, but the contact force is called contact because that non-contact force can only be activated when they are really close. Are you getting a point? What I'm saying? Every contact force is non-contact in nature, but that is only feasible, or that can only be experienced when you're really close to the other surface, right? So when you stand on the earth, on the surface, on the floor, are you actually touching the surface, or you're in a floating condition? Tell me. So when you stand on a floor, are you floating or are you touching?
So floating.
So we all are floating. So your laptop is floating on the table. So the other articles kept on the table. Everything is in the floating condition. But do we really feel those floating?
No, sir.
No, because the gap is small enough not to let you feel. So the brain, the touch is the brain way of saying a force is being exerted. So do we feel the touch, or do we feel the force? Like how brain will, activate our touch? Every touch will have different amount of force. So when you touch a feather, it will have a different sense. So you can call it a feather touch. You touch a wood, a different force, because the atoms of wood are different. A different set of atom will have a different interaction, and brain is so powerful to distinguish between these touches, isn't it? Understood what I'm saying? So the screen of the Apple phone is really smooth. We call it feather touch. But some old phone, or you can say if you buy a really cheap phone, their screens are not as smooth as the Apple. So what is the difference? The quality of glass they use, right? So the Apple having the patented glass. I mean, of course, that glass cannot be manufactured by other competitors. And because of that patented glass, the glass itself is the most expensive part of the Apple, not even the technology. Okay. So the entire touch feel. But if you go to a supermarket and if you go to the billing counter, you must have heard, okay, must have seen that they hit the screen very hard, the billing guy. If you go to DMart, you can see this. Have you seen? In fact, they hit it like a hammer with their fingertips. Have you ever observed?
Yes.
So that is also touch screen, no? But is it as smooth as the Apple iPhone? So there is the concept of a resistive screen and capacitive screen. So Apple uses the capacitive screen, where a slightest touch creates a signal. And the cheaper version, they use the resistive screen, where you have to press it very hard. And once you press very hard, it will detect the signal. If you just touch it, will not feel whatever is happening. So all this technological advancement uses the simple ideas of physics in a different way. Okay. So we'll learn, come to know all these things later on in a different chapter. So everything which I have explained here, this entire term which I have explained here, this entire force is basically electromagnetic force. So there is nothing like a really contact force. But why we call contact, I hope I have explained. So what is contact force now? So it is also a type of non-contact force, but in this case, for this non-contact force to be exerted, the two surfaces must be very close, and they're close enough, we call it. So it's a, you can say, convenient to call it contact force. Understood? So while you are holding the cup of your coffee or your milk or Bonvita or a Complan, again, it's a non-contact force. So when you shake hand with your friend, which force you exert on each other? When you handshake, which force you exert on each other? So I'll give you option. Gravitational force, electromagnetic force, nuclear force, normal reaction. Which force?
So electromagnetic.
The answer is you exert the electromagnetic force. Okay. So in nature, everything is electromagnetic. So our interaction is always electromagnetic. Understood? Okay.
Yes.
Next, we can go to the next concept. This is done. This is done. Okay. Let me remove this. So we need to discuss about the some terminology called inertia. What is inertia? Tell me. Any guess? What is inertia? Tell me quickly. What is inertia?
So the
Sir,
force which makes a body stay in the same place or move to change its
Yeah.
motion.
Well, inertia means it is the ability of a body in order to maintain its state of either rest or motion, right? Isn't it? This is
yes, sir.
inertia. So that's it. You have to say this only. So it is the word inertia has come from the word inert. So it has come from the word inert. Inert means lifeless, right? And because they're lifeless, can they change about their state? Can they change anything about themselves? So if there's a dead person, so it will move or it will remain there wherever it is, right? So can it move on its own? The answer is no. So who will move? That dead person. Someone else, some agent, isn't it? So what we need is some external force to move. Yes or no? Tell me, guys. So anything which is dead, which is inert, which is lifeless, they cannot change their own state unless someone else is applying some external force to this object. So that's why the word inertia means a lifeless event. Okay. And everything which is lifeless will have this property. What is the property? They cannot change anything about themselves. So that's why the word we use called inertia. Understood? Get this. Okay, quickly. So what is inertia? It is a property of any body by virtue of which it can maintain its state of rest or motion, right? That's the simple definition. Not the big deal. So you can say inertia is what? It is the property of, and see, all definitions are important. So it is the property of any body, or you can say particle also, by virtue of which it can maintain its initial state of rest or motion. That's simple. I mean, nothing big. So how many types of inertia we have? So generally there are two types of inertia, rest and motion, but it's still more sub-classification. So the types of inertia we can say as the first is inertia of rest. Second, inertia of what? Uniform motion. And third, we can call inertia of direction. Actually, the last two we can combine into inertia of motion only. So I'll write it here. Sorry guys, I'll take a. So once you know the type of inertia, it's a rest of motion. The question is, what is motion? When I say the word motion, so which variable defines the motion? Or you can say precisely state of motion. So state of motion is defined by velocity vector. So V vector is sufficient to explain all types of inertia. So when you say V equals to 0, I mean, let's say there is no velocity. So this will define the inertia of rest, isn't it? If something is moving in certain direction, if V is non-zero, then we have inertia of motion. Now, try to understand why we are defining all these things. The whole idea is when we say inertia of motion or rest, it is one of the state of the body. Now, if you observe that state of motion of body is changing, then what we must understand from that observation that some external force is into action, which is able to change the state. Because a body cannot change its state, yes or no? Tell me. Can a body change its own state?
No, sir.
So whenever we see the change of state, what we must infer? The presence of external force, yes or no?
Yes, sir.
Yes, sir.
So only external force can change the state. You cannot change your own state because that is against the law of nature. So the inertia is the real law of nature. The nature has blessed with this property. And the force is the cause to change the state. So force changes the inertia. Inertia is like well maintained. Now, inertia of rest and inertia of motion are measured in different ways. So mathematically, you will come to know. Rather, you should know that actually. So how we measure the inertia of rest? So let's say if you have different object at rest, let's say there is a dog at rest, there is a buffalo at rest, there is a big a boulder is at rest. So among the dog, the buffalo, or the big boulder, all are at rest. Can we distinguish or differentiate between the inertia of all three? Can we say which one will have more inertia of rest than the other? If all are having the inertia of rest, is there any way to compare the inertia of rest? That which one will have more inertia of rest and which one will have the less inertia of rest? Do we have some method to compare the inertia? Tell
Yes.
me, guys. So we don't have any method, isn't it? To compare the inertia. Do you realize this? That's very
Yes.
interesting. We do have a method. Now this is called mass. So mass is again a definition. Again, what is mass is a big controversial topic, but mass is a definition, or mass is something which gives you the measurement of inertia. So mass is the quantitative measurement of inertia of a rest. I don't have space on my hands. So if you want to compare which one will have more inertia of rest, a dog or a buffalo, I hope there is no need to explain. So which one will have more inertia? A dog or a buffalo?
Buffalo.
So both are sitting on the, let's say, roadside. So which one will be difficult to move? The one with a greater mass, yes or no?
Yes, sir.
Okay. So when objects are at rest, the mass will give you the comparison. That's simple. But there is a problem. The moment objects are set into motion by some agent, of course, then how much will be its inertia of motion? Mass alone cannot define. For example, if I have a bullet size object, let's say if I have a bullet whose mass is 100 grams, and if I take that bullet and if I throw towards you, will you be able to catch it? If I'm throwing from a distance, will you be able to catch it? Let's say you are a good catcher, you also play cricket, or you are a goalie. So will you be able to catch the small bullet size object?
No, sir.
Why no? I'm throwing it. I'm throwing that bullet towards you. Can't you catch it?
Yeah, yes, sir.
I'm not firing it. What I'm saying, I'm throwing it. Listen this word carefully. I haven't fired the bullet. I have thrown the bullet. There is a huge difference, isn't it? So if I throw the bullet, will you be able to catch?
Yes.
Now, if I fire the bullet, will you be able to catch?
No, sir.
So in which case it is easy to stop, when I throw or when I fire?
True.
You all realize, right, isn't it? You all realize this simple fact. But what you don't realize that the inertia is into action here. The faster moving bullet will have more inertia of motion than slower moving bullet. So inertia of motion also depends on how fast or slow the object is moving, isn't it? So definitely the mass is not the only way to understand the inertia. Mass is a way to understand the inertia of rest, but the moment you set some object into motion, the inertial character of moving object not only depends on mass, but also depends on velocity, isn't it? The inertia of moving object depends on what? Let's say if I throw something towards you with 1 meter per second, a small pebble and a big boulder, both with 1 meter per second, which one is difficult to stop, the pebble or the boulder? A boulder means a big stone. So if I throw both towards you with the same speed, which you can stop easily? The smaller one or the bigger one?
The smaller one.
But both are thrown with the same speed. but they have different masses. So can you understand that the inertia of motion does depend on mass, but can we say that it only depends on mass? Inertia of motion does depend on mass. Does it mean that it only depends on mass? Or
No, sir.
something else can also decide or dictate? So what
Sir, it
else
also
will
does.
decide? The velocity, isn't it? So what you need to realize that inertia of motion depends on two things. And what are those two things? Tell me. Tell me, guys, inertia of motion depends on which two factor?
Mass and velocity.
Rugved, tell me.
Mass and,
Inertia of motion depends on which two factor?
mass and velocity.
Do you realize it? You're just saying it because
No,
because
no,
Siddhant has said.
no.
You don't realize.
I realized it.
Are you sure you're realizing?
Yes.
100%.
Yes.
Pakka.
Yes.
Shall I lock it?
Yes.
No. Prashansa, tell me, inertia of motion depends on what?
Or mass and velocity.
So you realize it or you are just saying it forcefully?
I realized this.
Completely, right?
Yes.
So what happened in physics? We came to know about this inertia of motion, and it was known to Galileo. You can say prior to Newton. So the idea of inertia of motion is a very old concept. It is pre-Newton era concept actually. And Galileo Galilei from Italy, he was able to understand this inertia altogether at a very preliminary stage of development of physics. So this idea that the inertia of motion is a factor of two variable, mass and velocity, was later on combined to a single idea, which today we call momentum. So momentum is a fancy name given to inertia of motion. Today it is called momentum, but much before Newton it was called inertia of motion only. So momentum is a measurement of, because you all are aware of momentum is the mass into velocity, right? So momentum is, of course, quantitative. 1, 2, 3. Measurement of inertia of motion. So in fact, there's nothing like momentum in nature. We have inertia of rest, we have inertia of motion. And because inertia of motion depends on these two factors, so we thought of defining something which is proportional to the product of these two. And because we just wanted to have a comparison idea, so that proportional we actually made later on equal. So P is not equals to M. P is equals to, no, P is proportional to M. And these are called empirical relations. So you will come to know in physics, we have converted many empirical relation, many proportional relation into a concrete formula. Because at the end of the day, we are supposed to compare two things. So it doesn't matter how you start with, because your whole idea is to compare. So if you know this is this much and this is this much, and if there's a number associated with it, the brain can really compare it. So if I say a number 3, if I say a number 10, you know 10 is bigger than 3. Okay, so this is how the brain is developed. We always look for the number. So these all are developed for the human being to have some sort of a very solid comparison idea. Okay, I mean we can compare things. So in physics, as the development, proceeded in this world of science, everything was brought into a very concrete form. Sometimes it looks like they are real and they are actually, like some the law of nature. But the thing is, these are developed quantities. We develop these ideas. We kind of made it very concrete over the years, and it looks like they are really, existing in nature, and we have something like momentum. So momentum is basically an idea, the idea which can give you the inertia of motion. And therefore, many books are also called momentum as quantity of motion. Okay. So as you will study more textbook, you will also read this line, quantity of motion. Okay. So there are various names to the word momentum. So now today we have word momentum. We represent by the symbol P, and we write as product of M and V. Actually, it's a KMV, but we take K as one in SI unit because eventually we want to make some comparison. These are empirical relations. These are simple relations. There's no ground of it. Okay. But once you assume this as a formula or a relation, the other values you can compare. See, if I write P equals to MV and if I write P equals to 2MV, you know the other P is twice of this P. So that idea is important, nothing else. So P equals to MV, and as I said, this is empirical relation. It is also called quantity of motion. So if someone will ask you what is momentum, how you can explain? What is momentum? What should be the definition, guys? Tell me. Define momentum quickly. Who will define momentum? See, whatever I have explained is the definition. Just you have to convert this into literature. A definition is the idea wrapped in some nice grammatical sentence is called definition. So you have some idea. If you can really express the idea, it will become automatically a definition. So that is how, when I say definition, it means you have the idea and you're putting into a very precise format. Okay. So Siddhant can tell me what should be the definition of momentum? How do you find it?
So momentum of an object is the product of its mass and velocity.
No, that's very shitty one. I have explained what momentum measures. Momentum is the quantitative measurement of inertia of motion or inertia of moving object is measured in terms of momentum. You can say either. So what is momentum? See, I'm not asking formula. Formula is empirical relation, which we have developed. But what is momentum actually trying to explain to the world? Tell me. What kind of inertia momentum explains? Inertia of rest or inertia of motion? Tell me.
Motion.
It is definitely motion. Why are you confused? Siddhant, are you listening?
Yes, sir.
Yeah, so tell me, no? What we are trying to explain through momentum?
The inertia of motion.
Inertia of motion. So inertia of motion will be for the moving object, yes or no?
Yes.
The formula is given so that if you have two moving objects, then you can compare which one is having more momentum and which one is having less momentum, or which one is having more inertia to maintain the motion and which one is having less inertia to maintain the motion. So what really matters is the inertia of motion. And these are some subtle way of writing Okay, so if I want to define momentum, what I can define? Question, tell me.
The quantitative measurement of inertia of motion.
Yeah, it is defined as the quantitative measurement of inertia of motion, or we can say it gives the measurement of inertia of moving object. So when it comes to the comparison of inertia of two moving bodies, then we should look for mass and velocity. But when it comes to inertia of two bodies at rest, then we should look only for mass. Understood? Tell me, guys, is this clear? Yes or no?
Yes, sir.
All right. Okay, anyway, I hope this is clear to all of you. So momentum is not something new, it's a very old concept. Inertia of motion is an old concept. Newton simply converted that concept into a nice mathematical framework, and he made P equals to mv look really nice and really genuine. Okay. So inertia is clear. What is inertia? Tell me, guys, inertia is clear. The state of motion is clear.
Yes, sir.
Okay. Now the thing is, who will change the inertia?
External force.
The answer is external force. So again, there are two ways of thinking. One is, if you see in a certain situation that inertia is changing, then can we infer that some mysterious external force is into action or must be in some action? So when you throw a projectile, let's say you throw a projectile horizontally, does it carries the motion horizontally forever or it goes this way? How it goes? Down or straight? If you throw any projectile, how it will go? Tell me. So will it go straight or will it go parabolic?
Parabolic.
So you all are knowing this fact. It will go like this. Tell me, guys, yes or no?
Yes, sir.
So now tell me, the state of motion of the object or this projectile is changing or is it constant? So what you would like to comment about the state? Is the state maintained or is the state changing? Tell me, everyone. The state is constant or the state is changing? The state of motion.
It's a constant.
Huh? The state of motion is constant. What do you mean by state of motion?
State of motion is changing. Inertia is
The inertia is maintained or inertia is changing?
maintained.
Inertia is maintained. So you haven't understood what is inertia, right?
So because here there is no external force to
There is
change it.
no force. Are you sure there is no force? You throw a
So
projectile and
gravity acts as a force.
of course, gravity is acting as an external force. So I'm trying to say in different way. I'm saying that see, when you throw, you know the path, right? So looking at the path, what you can say? The inertia is maintained or inertia is changing.
Changing.
Let's say you have no idea about gravitation. You're born before the Newton. Let's say you're born after Galileo and before Newton. So you know inertia, but you don't know the idea of force. Now, if I'm asking you the question that if you throw a projectile, the inertia is changing or inertia is maintained, what you will say? Looking at the actual path of projectile, what will be your comment? That the inertia is changing or is it maintained constant?
Changing.
It is constantly changing, isn't it? Because the direction is changing all the time. Yes or no?
Yes.
In fact, magnitude is also changing, but at least can you see the direction change? So here the velocity vector is constant or variable. Tell me. The velocity
It's a
vector is
variable.
constant or variable? Yeah, it's variable.
Variable.
So inertia of motion is changing, yes or no?
Yes, sir.
So momentum is changing, yes or no?
Yes, sir.
Because inertia of motion now today, what we call, how we measure it? Inertia of motion. How we measure the inertia of motion? Tell me, guys.
Momentum.
In terms of momentum, isn't it? So if the projectile which you have thrown is moving in the given path, can we say momentum is changing all the time? Yes or no? Tell me. Rugved,
Yes, sir.
tell me. Rugved,
Yes,
tell me.
sir.
See, unless you're not realizing every single piece of information, do not proceed in laws of motion. And let me tell you, the amount of effort you will put in this chapter will make you extremely good and strong with the rest of the physics. Don't try to hog the entire physics at once. See, people, what they do, most of the students, they try to become good with physics in the future chapter, and they want to finish this initial chapters as quick as possible, and that is a mistake. Physics is only first few chapters, the rest is application. And those who have understood the first few chapters really well, they never find anything in physics difficult. The rest is some manipulation, some sort of application, some new definition, terminologies. But there's no physics there. So whatever physics you're learning is the first 4 chapters. That's it. So I'll prove it that this is physics you're learning. And laws of motion is the second building block. First is kinematics. So you have learned how to manipulate when you know the state. And now what you're going to study now in this chapter? The agent behind the change of state. This is the difference between the first chapter versus second chapter. So first chapter is called kinematics. Kinematics is a branch of physics in which we study about motion without knowing its. Understood what I'm saying? The first chapter is called kinematics for a reason. In the first chapter, we never thought about the agent, isn't it? Were you worried about the agent who is creating the change of direction? No. You were knowing the acceleration, you applied it, you got the answer, isn't it? Hello. Are
Yes.
listening what I'm saying?
Yes, sir.
In the first chapter, you were knowing the force, you were knowing the acceleration, initial velocity, and you got all the other answer because those information was known to you. What we are going to do in this chapter? We are going to investigate the agent who brought the change. So when you study motion with its cause, like who created the motion, who changed the motion, who started the motion. When the who comes into picture, the chapter is called laws of motion. And if you understand this subtle difference, you can nail this chapter. So who will change the inertia here? The answer is external force. Now the question is, let's investigate. See, I'm trying to make you Newton. Think this way. So you're born in the era of Galileo. You were knowing the inertia. And now you grow up to the era of Newton. And then you realize that the inertia can be changed by the external force. Okay. Now, common sense. Tell me common sense. Do you see any physically touching force here? Any contact force? Do you see?
No, sir.
So it could be one force which is the air drag, but if I ignore the air presence, if I ignore the the interaction of the projectile with the air, then do you see any contact force here? Yes or no? Siddhant, tell me. Ignoring the air resistance, do we have any contact force here for this projectile while it is in air, while it is flying?
No, sir.
Now, if you remember the definition, based on the origin, how many types of force we have? Only two types, right? Contact and non-contact.
Non-contact.
There are only two types of force in nature. Either it is contact or it is non-contact. And what you can realize by your common sense, that there is no contact force. So which force we are left with? Which force we are left with? If contact is not there?
Non-contact.
Non-contact. Now, we know from the fact that Earth is an uncharged particle, so there is no idea of charge. Even in time of Newton, he was not aware of charge. So what kind of interaction is there? It is the interaction between the projectile with the Earth only, yes or no? So this force, what we call force of gravitation, right? And if the projectile is flying close to the Earth's surface, can we call this force acting vertically downward? Yes or no? Tell me. So the force that this projectile is always experiencing is mass of the projectile into gravitational acceleration value. G is a value, G is not a acceleration, G is a value which is 9.81 meter per second square. But G vector is called acceleration vector. So when I write only G, it's a value, but when I write a G vector, it's a acceleration vector. So mg is the value of gravitational force. And it is acting all the time, and that is why this is responsible for change of momentum. So who changes the momentum? The answer is force. Which force? External force. And that eventually became the Newton's second law. So Newton defined things in the reverse order. So anyone knows the Newton's second law? You all have studied in your high school. Can you define Newton's second law quickly? Can you define the first law? A body at rest remains at rest. A body in a state of inform motion remains in a state of inform motion unless until acted upon by some external unbalanced force, right? This is
Yes,
how you
sir.
define the first law. So the first law itself is the law of inertia, isn't it? So either you call first law or you call law of inertia, it is same. And it was not given by the Newton, it was given by the Galileo first. So Newton's first law was simply the coding of Galileo observation. So inertia, the idea of inertia was present with Galileo a long time back. And he gave all this idea of inertia. Newton only formulated this simple observation. So what Newton said that, okay, any body either at rest or in a state of uniform motion will continue to do so unless acted upon by some external unbalanced force. Simple, fair enough. That becomes the first law. Anyone knows the second law? Anyone?
So force is the rate of change of momentum.
No. You need to understand this. Newton defined things in the reverse order. So first he made the observation, and now he realized that the force is the cause and the momentum change is the effect. And you're trying to define cause in terms of change in the effect. So what Newton said in the second law, it's hard to understand how big the force is. So a bigger force will make a bigger change of effect, a quicker change, yes or no? Tell me, guys. As force will have a bigger value, a bigger force can make a bigger change, right? A quick change, yes or no?
Yes.
So Newton is saying that, see, if you are changing someone's momentum very quickly, then force is going to be really large. So the cause and effect was put into some literature, which is now called the Newton second law. So can you try to convert that literature in your own words? Then you are really understanding the Newton second law. No need to mug up. So Newton said that the rate of change of momentum. Now, what I just said was the change of effect. The rate of change of momentum is what? Rate of change of effect, because momentum is the effect, isn't it? Momentum is the inertia and change is the effect. So the rate of change of momentum will be what? Directly proportional to the rate of change of momentum will be directly proportional to what? Tell me, guys. Who will change the momentum? We just discussed
External force.
external force. So the rate of change of momentum is going to be proportional to what?
The force applied.
The applied unbalanced external force, right? Or external unbalanced force, isn't it? The applied external unbalanced force is the reason behind the momentum change, isn't it? But Newton defined the reverse process. He said that the rate of change of momentum is directly proportional to the applied unbalanced external force. And he said the next line, which is difficult. And if you try to find the direction of delta P vector and the direction of momentum change will be in the direction of applied force. And if you combine this entire literature, it becomes the second law. And the day you're able to say this law on your own without referring to any textbook, without mugging up, you have really mastered the Newton's law of motion. If you can really say this line with complete realization in your mind. So you will have some lecture right now, but this chapter will be very organic. I will not try to force you with any formula. Rather, we all together will try to absorb the reality as seen by Newton, not what you feel. So as of now, we'll only stick to the definition as given by the Newton, and we'll try to think accordingly without applying our own common sense. Understood? Okay. So you can take care. We'll see in the next lecture.
Bye, sir. Thank you, sir.